Welcome to the second part of the survival analysis video. In this video, I'd like to show you how to create both a follow-up life table and a Kaplan-Meier life table using the example from your textbook practice questions. And so in this practice question, basically, they gave you a list of people who have died and a list of people who were basically censored. They were still alive when they got to the end of their time frame, so that nothing happened to them. And so I want to show you the difference between a follow-up life table and the Kaplan-Meier life table in creating those. So I'll create the first couple of lines as we go along and kind of show you how that works. So in both cases there are 25 people, and in the follow-up life table, let me show you which cells you're going to be filling in. You have to fill in where you start, and then we also have to fill in how many people either died during that interval or were lost to follow-up during that interval. And it could be that they were alive, or it could just be that they were lost to follow-up. We don't know what happened to them. But this is how the example is written for your particular question. So we start off by needing to fill in these numbers, and then I'm going to use Excel to calculate the rest of the line here, and you can see the actual equations that go with those particular columns. So the number of deaths during this interval between 0 and 2, and what the parentheses on the left means is that it's everything above 1, and the bracket on the right means that it's inclusive of 2, but it doesn't go beyond 2. So if you had a 2, that person wouldn't end up in both of these rows. For this second row, it's everything above 2.0, so it could be 2.01 or 2.05 or 2.1 would be here. And if it was 2.0, then it would be included here. So the bracket is inclusive and the parentheses is not. So that's kind of a common nomenclature in survival analysis, just so that you can kind of be familiar with that. So here I have a death that occurs at 1.2, and that's in my 0 to 2 category. And so I'm going to put that right here. First of all, I want you to notice that I took those 10 years and I split them up into even categories. You could very easily split them differently. You could split them into 2.5-year categories and have 4 categories: 2.5, 5, 7.5, 10. There's nothing wrong with that. There's nothing magical about 2 years. This is just one way of doing it. So then I have 2.5 and then 4.3, so I guess that's going to be a 1. And then this next one has 4.3 and 5.6, so there are 2 here. And then we have 6.7 and 7.3. Those both fit into this category. And then 8 to 10 has 1 because there's this 8.1. So that's how I'm going to fill in this table. For the lost to follow-up, this first category I don't have any, and then I have 1. Again, you would have to look at the numbers here: 4, 4, and 9 in this following category, including all the people that lasted all 10 years. So basically, the first thing that I would like to do is I want to calculate out how many are at risk during that interval. And so we start off with 25. This is going to be equal to that 25 minus the ones that died and minus the ones who were lost to follow-up. So I end up with 24 here. And the nice thing about using Excel is that you can just ask it to do the calculation for you, and it's not prone to errors, as sometimes we are when we use our little hand calculators. So all of these were calculated. The next thing we need to think about is that in this particular type of the follow-up life table, what we need to actually use is the average number at risk during the interval. And so what this does is it subtracts out half of those that were lost to follow-up, because we don't know when they were lost. They could have been lost a day after the last time we saw them, or it could be that they were lost at some point in between. So we're assuming sort of an equal distribution of loss to follow up by dividing this by half. So basically we're going to take the n sub t, which is the number at risk at the beginning of that interval, and subtract out half of the loss to follow-ups. And so in this case, we're going to say equals to the 25 minus c sub t over 2. And so that basically will get me my average number at risk during the entire interval. Since this is 0, it should still be a 25 here, which it is. And the nice thing then is this is going to just calculate those out for you. And so we have 23.5, 20, 14, 5.5, and so on. So now that we've calculated this number, that's going to be used in this column that is the proportion who died during that time frame. And that's basically the number who died divided by the number who were at risk during the interval. And not just the number at risk, but the average number at risk. And so this is going to be equal to the number who died divided by the average number at risk. So here we have 0.04. I can fill all of that in. I don't like to have so many decimal points. I probably would format that so that it would only give me 3 or so. Something like number, 3 decimals possibly. So that's probably good enough. The proportion surviving is just the inverse of that. So it's equal to 1 minus that number. And so we're going to end up with 96% surviving. 1 died out of 25, so we have 96% surviving. And we could drag that number down here, and we end up with, at the end, each interval has its own proportion surviving. Now, the thing that you probably remember is that at the beginning there were 100% or 1.0 surviving. And so this number here is just going to be equal to the percent surviving in that particular row, because it's times 100%. But then each time you go down to the next column, basically you have only 96%, and then you have 95.7% of the 96%. And so this ends up being this s sub t minus 1 is 0.96. The p sub t is 0.957. So this is going to be equal to p sub t times the previous number. And so again, I want to get rid of all that extra information. So let's create something with just 3 decimal places. We could turn all of these into percents as well. The survival probability is always going to be between 0 and 1. So that's like 0 and 100%. And then you could drag that down and fill in all the rest of the survival probabilities for this case. Now remember, for the follow-up life table, we split this into even categories, into even buckets, so to speak. And so there were a different number that were lost to follow-up or died during that particular interval. And so then given these survival probabilities, that's where you can make your survival curve for the follow-up life table. The Kaplan-Meier is different because every single time we get to an event, whether it's a death or a censored, and they were still alive at the end of their particular time, then we're going to create a new row for that person. And so here we have 1.2, 2.5, 3.4, 4.1, 4.32, 4.3, and so on. So each one of those is going to get their own row. And the calculation, again, is based on starting off with 25, and then we'll do the calculation as we keep going. And so how many died or were censored at time 0? None. So we'll just sort of leave that empty. But the number of deaths, I started filling these in based on these numbers basically. So at 1.2 there was a death, and at 2.5 there was a death. And then at 3.4, there was a censored at time 3.4, and at 4.1 there was a censored. So you would need to just continue this table all the way down to include all 25 people, and sometimes more than one thing happens at the same time. For example, here you have a 7.3 that died at the same time as a 7.3 who was censored. So both things happened there. So here we're going to do the same calculation. We're going to say equals the starting number minus each of the death and the censored, and then we can tell it, go ahead and calculate all the way down to there. So you should have 25, 24, 23, 22, 21, 20, 19, 18, blah, 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 all the way down to the bottom, except for if two things, maybe there were two deaths even that happened at the same time, or two censored, but here we have two things happening at the same time interval, and that's going to be a little farther down on your graph. This percent right here that has survived, the P sub t, which is the same proportion surviving, at the beginning is going to be 100% because we're starting at time 0. But then each time after that, it's the number at risk minus those who died divided by the number at risk. And so this is going to start decreasing as we go. So this is equal to, let me get my parentheses, 25 minus the number who died, and parentheses, divided by the number at risk. And so that gives us the proportion surviving. And there's your 96%. Let me actually make this, we'll get rid of all the extra numbers right out of the gate. We'll allow for 3 decimal places. So the survival probability, again, is equal to the survival of the previous row times the survival of the current row. And so that first time we get 96%. And then here, one thing that you'll notice is that the proportion surviving when things happen that are censored actually does not go down. And so here we can fill those in. So as soon as you have a death, then the survival probability drops. But each time you have a censored event, each one of those stays exactly the same. And that's because of the way we see the proportion surviving. Let's go ahead and go, let's go a little bit farther. 4.1, I think the next one is 4.2, and then we have 4.3. And you can see what happens as soon as we get past all of these ones that are censored. Let's go ahead and copy these down the next 2 rows. As long as you have censored events, the survival probability doesn't go down. But then as soon as you get to another event, that's where it drops. So each time you have a death, your survival probability goes down. But each time you have a censored, the only thing that drops is your denominator. So for the proportion surviving, so it doesn't actually drop down. So what I'd encourage you to do is finish out the rest of this table, finish out the rest of this table, and then you will have created the Kaplan-Meier tables for both of them. Then your last task is to sketch the survival function, and most people complete that just by hand. You can draw it on a piece of paper. You could, it is possible to do it in Excel. The thing that you have to remember is that you're drawing both a horizontal and a vertical line if you're trying to draw those step functions, and we can show you how to do that if you're really interested in it, but doing it by hand is actually a really very good experience, because when you learn by your thoughts going from your brain into your hand, to draw on a piece of paper is very different than if you were just trying to program a computer. So to draw those is actually a really good experience. And then I'll post a survival curve that shows what yours roughly should look like when we get to next week. So thank you so much for joining me for this exercise in calculating and seeing how that's different for the follow-up life table and the Kaplan life table.